Hello everyone, thank you for joining us today. My name is Peter Milne. I'm the Director of Application Engineering at Aerospike, the flash-optimized in-memory open-source NoSQL database. Our guests, Evan MacZura and Aaloan Miftah, CEO and CAO of SmaRTB, are joining us today to share with us how they are using Aerospike and how it will support their expansion plans. SmaRTB is a self-serve, real-time mobile ad network startup based in Tulsa, Oklahoma. They have started live traffic and are already handling more than 1 billion ads per month globally and expect to see a massive growth shortly. Before Evan and Aaloan introduce themselves, I'd like to remind the listening audience that you can submit questions using the button on your viewing screen, and we will address them during the Q&A after the presentation. Evan, over to you.
Thank you, Peter. Again, my name is Evan MacZura. I'm the initial co-founder of the business, as well as Aaloan Miftah, who is our brilliant developer.
Hello, I'm Aaloan Miftah. I'm the brilliant developer for SmaRTB.
That's us. As Peter mentioned, we're based out of Tulsa, Oklahoma. You may know it as the #1 startup city, I think, by Forbes, which is kind of cool. In short, we are a mobile ad network, as he mentioned, and the idea for our network came out of the personal limitations that we had come across when running some of our own advertising across existing ad networks. I guess I covered some of those. Here's a brief diagram kind of our network structure, I guess. The logos at the top, Mopub, Smato, MobFox, and GumGum, are the ad exchanges, essentially the traffic sources that we get requests from, anywhere from 10,000 to over 100,000 requests a second. That we have to respond to and handle each one, which in short is where Aerospike comes into play, is we really rely on the speed to be able to make these decisions lightning fast. Of course, our requests go through a load balancer, through to our processing nodes, and across the Aerospike and storage clusters. And here's just a small diagram of kind of how the click flow happens. Once an ad is served from a CDN, it will be displayed on the user's screen. Once they click on it, we'll go ahead and look up the information regarding that ad and update the database, marking it as clicked essentially, and the user will arrive at their destination beautifully. Regarding our internal storage challenges, being an ad network, it's unique as we handle massive amounts of data that typical storage solutions, of course, such as MySQL and such, wouldn't work super well for, and would not allow us to operate within the 1 to 200 millisecond operating window of the real-time bidding spec. With that, we also have to be able to query and reduce massive amounts of data to pull statistics essentially in real time for our users and internal monitoring as well. We've compared quite a few storage solutions, primary of which previously was Couchbase, before finding Aerospike and some of the benchmarks, of course, I'm sure everyone is aware of. And after doing the comparisons, it was clear that Aerospike was the best fit for us for many reasons. Of course, one of the awesome ones here is the recent release of the Community Edition, allowing us to achieve industry-leading performance at no cost at the moment, and we're still getting absolutely awesome support from the Aerospike team, and we're very thankful for that. Of course, along with the performance, there's bragging rights as well as actual savings costs. Since we can run less nodes, of course it saves us money on not only servers themselves, data center costs, complications, maintenance, and everything. And one of the cool parts I find about Aerospike is the fact that it is SSD optimized. It includes functionalities such as wear leveling and everything, which would maximize the lifetime of an SSD disk, as opposed to perhaps traditional databases where the write lifespans are different, operate differently. Last but not least, the UDFs are definitely our favorite functionality in Aerospike, and they allow us to do awesome things to pull all of the data, all the statistics, all the reporting information, essentially everything, and we can do a lot with it. And we'll cover that a little bit more here in a second. Along with Aaloan, we'll give you some insights as to how we're using it. And of course, the Aerospike monitoring client, web-based monitoring client, where you can log in and easily view the current stats of all of our clusters, each of the individual nodes, get information such as current usage, transactions a second, whether it be reads, writes, any potential errors that are happening, such as data eviction, and monitor the difference between our individual clusters and overall performance and health. One of the big benefits, again, that we've found when running Aerospike is the ease of use overall. Setting them up on a CentOS node literally takes 5 minutes. You can sit down in front of the server, pull up the terminal, and literally get running in 5 minutes. And the documentation, of course, is beautiful. It's very easy to find, easy to navigate. No questions, no missing information there. From my personal overview as well as discussion with Aaloan, the APIs are well documented as well, very clear, and the learning curve isn't too bad either. Also, cluster discovery, if you add nodes or anything, they're auto-discovered, so there's no complicated setup, no configuration, anything hard of that sort. It will do most everything for you. It is extremely nice. Yep. You may have heard about the UDFs a little bit. In short, they are user-defined functions, somewhat similar to stored procedures in MySQL, however, much more powerful. I'm going to go ahead and pass this off to Aaloan Miftah, who will give you more bit of an overview specifically to how they function and how we're using them in our internal applications.
All of the UDFs are written in Lua as opposed to where Oracle SQL, they seem more or less like stored procedures or whatever. They're per record or streaming. They can aggregate data. They can reduce, map, filter. They can do almost anything, and they're in a pretty well-featured, or they're written in a pretty well-featured language, which is Lua. For its performance and size, it's extremely exciting to work on them, and it's extremely beneficial because at the end of the day, we achieve quite a bit of speed in comparison to what we would have achieved with stored procedures or something of the like. They execute in parallel they execute distributed nodes in parallel natively. So whereas if you were using Cassandra, you'd have to use something like Hadoop in order to be able to do distributed computations and things like that. They do that by nature. They run on Aerospike nodes producing extremely high performance, and they can natively handle complex logic, and you can further extend that with C modules to add whatever else you need, for example, bit operations or some light form of floating point operations, although obviously you can't store floats in Aerospike. This is an attempted diagram to demonstrate how we're
primarily using UDFs within our application. Since our network is unique in that we allow people to do multi-point targeting, it's basically a set of conditions or a set of criteria that the impression must meet or pass through in order to determine whether we even want the ad at all. And what this does is allows our advertisers or our customers to get very specific and much more granular with their targeting and purchasing only the ad inventory that is valued to them. Or as opposed to before with the current limitations of ad networks, you're basically forced to kind of take the stuff on the side what's left because the platforms are not advanced enough or targeted enough to allow you to pull just specifically what's valued to you. This is an example where if the targeting rules were to block an application of Skype, so if a user opens up the Skype application and their carrier is Sprint, specifically, if those two conditions are satisfied, then we don't want this. However, if they're on Skype and any other carrier, they are willing to bid on it. So that allows them to get the specific targeting, I suppose, that is really critical, where high volume, low margin advertising type is in place, as well as in a field where there are so many data points within mobile, of course. Unlike desktop, there's everything from phone model to brand, carrier, location, the application, publisher ID, publisher type, so on and so forth. And previously, there's no way to combine these to test for the quality or to cherry pick the traffic. And now we're introducing that, and UDFs play an extreme role in doing this data filtering basically for us. And again, that is distributed per node, which is awesome because it saves some work on some of our, I guess you'd say, worker nodes. As a small recap, again, of particularly why we've chosen Aerospike and how we're using it, you can store tons of data with minimal hardware node considered other storage solutions currently. And again, a lot of this performance is achieved through keeping indexes in RAM and very stringent choices on the storage solution used. So really no corner has been cut here as far as performance goes, or reliability even. And of course, critical to storing tons of data. Storing tons of data isn't usually too useful if you can't do anything with it. UDFs really are a Swiss Army knife here. You can do pretty much anything you can set your heart on. Another cool point of Aerospike is it'll actually balance the data between nodes in the cluster as well. And the Enterprise Edition includes cross-data center replication as well. And again, a lot of the stuff is extremely easy to set up, if not trivial, and pretty much handles itself. So it allows us to keep our hands off of required maintenance or fixing little bugs and focus on product development and running the business. And of course, it's been extremely easy to get up with. Setup times were very simple. Everything is very well and clearly documented, which is very important for us as developers and the reading type. And the Aerospike team has just been awesome. Any closing words, Aaloan?
As far as the UDFs go, the actual design is pretty brilliant. They're written in Lua, and Lua is a fast, small, feature-rich language, and as I said before, it's easily extensible via C modules, which in turn makes the UDFs fast, easy, and robust. They can do complex things via the C modules, obviously, for example, even network communication. execution is obviously distributed, and they're easy to maintain, and they're not as ugly as SQL stored procedures.
Frankly, or hackish, kind of. Overall, our impression of Aerospike is absolutely awesome. Our experiences have been wonderful. Unlike general storage platforms, you always run into some take or give, and so far I can honestly say I don't really think that we've had that whatsoever. We have the ability to store extreme amounts of data at extremely high rates, and we can actually handle, query, reduce, do basically anything we want with that within the required amount of time. And we're talking about milliseconds, if not less, which is crazy in terms of if you were to have a SQL database or anything standard, you'd have to have an insane amount of nodes, tons of time, tons of manpower to upkeep this stuff. Not to mention setting up replication and everything, which Aerospike is just beautiful and it literally does it for us. Going to go ahead and turn over to some of the questions here so far.
Thanks, guys. That's a great presentation. It gives us a great insight into your use of Aerospike. Just a reminder to everybody who joined a few minutes late, you can submit questions with a submit button on your viewing screen. But before we start with the questions, I have some of my own. So, guys, how easy was it to learn Lua and write user-defined functions?
Lua is extremely simple. I actually knew it ahead of time. Our build system is actually written in Lua, but when I initially started learning Lua, it was extremely simple. There's simple constructs. For example, there's no braces or anything to open functions or close the functions they have, and as for to end each block. And just a reminder, indices start at 1, not 0. That was quite a struggle. That was the only thing I didn't. That was whenever I first started writing some of the Lua components of the build system. I couldn't get used to the fact that 0 wasn't an index, or it started from 1. That was extremely weird.
Okay, and implementing user-defined functions.
They're extremely simple. Once you know Lua, you basically, it's extremely easy to implement user-defined functions. It's easier to implement record UDFs, and then for streaming UDFs, you have to think a little bit outside of the box, and that normally forces you to come up with great solutions.
Great. How do you find the performance of the streaming UDF, the real-time analytics of Aerospike?
We're actually currently using them. We have quite a bit of data in one of our sets, and every time we get a request, we traverse through all the bid requests or the bid impressions or campaigns that match some crazy criteria. That all runs through the streaming UDF. It does aggregation, reduction, mapping, etc. We also use it in our reporting platforms. So the performance is extremely nice.
Critical.
Okay, let's look at some of the questions that come in from the field. Could you share with us some of the challenge you encountered with Couchbase?
Sure. In short, just the performance isn't quite as high, of course. In my experience, the configurations are, of course, different. Aerospike has been extremely easy to set up and is a hands-off thing to handle replication, data balancing, ASIN compliance, so on and so forth. As well as, again, one of the main points of using Aerospike was the availability of UDFs playing a critical role in the ability to make our platform function the way that we want it to. Again, handling the criteria in processing that, such as Aaloan just mentioned, since we can do that now distributedly through the UDFs, that was a big vantage point for us over something like Couchbase.
Okay. Another question is there any reason why caching would not have worked for you?
Caching, well, it depends. Caching in what context? For the campaigns or the bid requests. This is basically real time, and if we can get the data in 2 milliseconds as opposed to caching the data and storing it for, I don't know, 2 seconds or something and then getting stale data, bidding based off of that, it kind of defeats the purpose of real time, really. So since our purpose was to be real time, Aerospike is real time. We also are real time.
Within the millisecond or less. And at this point, essentially, we can achieve, you could say, caching inspired performance through Aerospike alone. So there's no need to go, I guess you'd say, the extra mile to try and set up any form of caching, to where in this case it's just simply not required. We don't have to worry about supporting that, whether it be from hardware perspective, development, or anything. Aerospike has all of these features as well as performance and robustness to do everything that we need.
Developers are normally brought up or taught that caching is a good thing, but caching is relatively evil, and if you can get away from it, it's beneficial. At least for us, it's been great.
Okay, great. Let's take a few more questions. Have you integrated data from systems like Hadoop with Aerospike?
For the network, we have not. We've developed thus far solely with Aerospike.
That's great. That's great. Could you comment on... Go ahead.
I was just going to say, that is as far as our overall functioning network goes, of course. Again, we looked at many other storage systems and everything, though ultimately Aerospike through the UDFs provided a huge functional point that we required within our network to make it work, period.
Okay. Another question. Could you please comment on the Aerospike SSD-based storage versus the disk alternative and the cost comparisons? What did you find?
Well, essentially, it would be very difficult to get the same performance from a disk-based storage solution without something, of course, like caching or the inbuilt caching with Couchbase. And with that, we would need many more nodes, which incurs additional, not only upfront server costs, but data center costs, maintenance, everything as well. So the disk-based stuff essentially just couldn't keep up for us.
All right. I have a two-part question from the field. What types of errors and or issues may occur when using UDFs? And the second part is, are there any corrupted data that may occur, and how do you fix them?
The only errors or issues, well, actually, if you're not extremely careful, you can actually cause seg faults in some regions of the code. So obviously you have to take some precautions for that. However, aside from that, there are no errors. If a UDF can't compile or if there's any logical errors, obviously it will, or compile time or runtime errors, it will obviously just fail and return back. As far as corrupted data goes, Aerospike is ACID compliant, and you can even use, I think, the operations API to get some of that atomicness of atomic operations, basically.
Okay. Another question from the field is, what SSD models are you using? Are they low-cost commodity or high-end like Fusion.io?
That's definitely a good question. As with any business or startup, costs are a huge deal. I'll put it in perspective here, I guess. We are basically a couple of guys, longtime developers out of Tulsa, Oklahoma. Our complete network and business is self-funded and everything, so of course costs have been critical to us, and that's again where we're extremely thankful to Aerospike and their team for making this possible for us as well as everyone else. Regarding our existing hardware, in addition to the AC tests that Aerospike has done, we've also tested quite a few drives, and currently we're using both the Intel S3500s as well as the Seagate 600 Pros, which can still be found for a pretty darn good deal, and pass the tests quite nicely, are very consistent performance-wise over a long amount of time, and can handle quite a few transactions a second within that strict 1 millisecond-ish time frame.
Okay, that's brilliant. Another question, how many nodes are you currently running, and what's your idea of scaling? What's it going to be in the future?
At the exact moment, I think our entire network consists of roughly 7 nodes, one of which being a super micro blade server. And at this exact moment, again, the network isn't live just yet. We're doing all of our internal testing, internal running and everything. So currently we have 3 Aerospike nodes, I guess you'd say, in production at the moment. 2 of which are for our live and purchase data and everything, such as actually storing the ad impressions, campaign settings, so on and so forth. And then the other one is to store or archive data, basically. And essentially why we just have one for that is it's rolling. It only stores 3 days worth of rolling data at the moment. And this is just for us to be able to pull historical reports and get insights as to what our network's doing, what kind of traffic we're getting, so on and so forth, so that we as well as our future customers can make more informed decisions regarding their campaigns and be familiar with the inventory and the ad space that they are purchasing. Regarding moving into the future, once we do go live, especially down the road, we will have more nodes. We don't have specific planning out for that just yet, as since we're currently in the gathering data phase. We're just now getting, I guess you'd say, supporting data to figure out realistically kind of what our requirements are. However, we're definitely staring at some of those fancy 12-plus drive servers with 256 gigs of RAM.
Okay, so here's another question about scaling your cluster. What code changes will you need to make to scale your cluster?
Absolutely none. Boom. That's why Aerospike is so easy to use. It will manage all of that for you, basically. Or actually, there's only one change that you might have to make. Just add the IP to whatever client API you're using. However, that's pretty trivial.
Okay, we'll just take one more question, and then we'll wrap it up. Do you use secondary indexes, and if so, how do queries using them compare to simple primary index queries?
We do use secondary indices. They're obviously a tiny bit slower because they do have to do some form of operation. Like, for example, if it's a range filter or an equals filter or something of the like. But they're extremely fast as well. And if I remember correctly, they're also stored in RAM, so that's where their performance is relatively the same.
Brilliant. Well, thanks again and for listening and participating in this webinar. Hopefully you've got some great ideas from these guys. Just on a personal note, I think these guys are 2 of the sharpest guys in the ad tech industry. Again, I'm Peter Milne, the Director of Application Engineering at Aerospike. I've been speaking with SmaRTB CEO Evan MacZura and CIO Aaloan Miftah. If you'd like to review this presentation later, it will be recorded and available on your YouTube channel. Thanks, Evan and Aaloan.